So, without further ado, this evening we welcome Professor Mark Williams from the University of Leicester, Professor of Paleobiology. I got that right, did I? Yes, okay. So his research over the last 30 years has taken him all over the place and all through a large part of geological time, at least the bits that have fossils in. So yes, you seem to have studied in all sorts of interesting places, from San Francisco Bay to Leicestershire and other such exotic places. So we've been, we're used to hearing about dramatic things in our modern catastrophist view of geology, such as climate change causing mass extinctions and super volcanoes and asteroid strikes. But now, this evening, we come to dealing with the most dangerous thing of all, which is us, apparently. So without further ado, I'll hand you over to hear our presentation for the evening. Thank you, Mark.
Switch that on. Okay, David. And to Mr. Booth, especially thank you for coming to to explain it from a paleontologist perspective, because I'm a paleontologist, and I think there'll be a wide range of geology within this talk. So Anthropocene, a planetary scale changed the biosphere, and hopefully I can say something about the future well-being of planet Earth also. I've got three different aspects that I'd like to talk about this evening. The first is really to talk about the Anthropocene and what it is, and what's actually causing it, because it's not just you and I, as I hope I'll be able to show you in a bit. And we need to go on to how we might actually define the Anthropocene. And we're actually in the process of finalising the Anthropocene at this very time. And we're voting on the potential boundary stratotype and where that will be placed. So I'll give you a little bit of an insight into that as well. Because in the paleontologist, I want to kind of emphasise paleontology's role in defining the Anthropocene, because it's been very important, although there are many other geological disciplines that have contributed to defining the GSSPs too. And at the end, I'd like to introduce a little bit of polemic, if you'll allow me to do that, just to take stock of our impact and make a few comments perhaps about how paleontology might be important in terms of us thinking about how we're changing the planet and how we need to interact with the natural world going forward. So let's begin with the Anthropocene and actually defining it. And I kind of need to take you through a whole series of figures. Got plastic here obviously at the start, and plastic is certainly a major feature of the Anthropocene, as I'll show you a little bit later. There are 8 billion of us on this planet. As about 2 years ago, in fact, we crossed this major population boundary. Increasingly large structures. So 8 billion of us on this planet, the century, that's the same. Urban species for the first history. Trajectories shown by the middle of this century would be similar to about 68% of us living in urban areas. And it's important because the structures of urban areas on this planet. 70% of jobs consumed is urban soil. 70% of all the pollution, all the stuff that we spew out as a species, is also centred on urban centres. So if things are going to grow and become more prolific at the surface of our planet for the 21st century, that's clearly going to present a major problem for us in terms of how we interact with the rest of the Earth system. And those structures also, for me as a geologist and a paleontologist, those urban structures produce some really radical paleontological signatures. I travelled on the Glasgow subway to get from Glasgow Central to my hotel. That's a trace fossil system in the making. Those are burial systems. And in the future, those are burial systems that would be there as a permanent record of you and I. right across the whole of this planet. So Glasgow subway is obviously one of the first. In fact, I think it's the second one, isn't it, in the 1890s. But over the past 15 decades, subway systems have spread across the earth, and they will leave a permanent record of you and I that will be preserved long into the future as a fossil record of humanity's impact on this planet. So I've started with a few figures. There are 8 billion of us on this planet, but I just wanted us to give a kind of counterpoint between this as a species and some of our real relatives, our closest cousins, in fact. How many do they remember? Let's look at the closest relatives to humanity. The chimpanzee, about 250,000 in the wild, and the beautiful bonobos, the 20,000 of them in the world, and over 8 billion of human. Let's just contrast that with the population of chimpanzees on this planet is Aberdeen. And the population of bonobos on this planet is nice. It is that you and I are 99.9% and more of apes on this planet. It's not just taking apes, that's taking all primate species or monkeys, lemurs, everything. 99% which is an amazing figure, a staggering figure, but also quite a depressing figure to think about. And in particular, over the past century or so, but over a very long period, of course, our influence on the planet has been growing very rapidly. These are some of the graphs produced by Stefan, who's a member of the Anthropocene working group that I'm part of also. And Stefan is a system scientist who's based at the Australian National University. And we colleagues did a couple of decades ago now, was actually just to try and assess some of the patterns of the 20th century in terms of these changing human patterns of consumption. And these are just some of his graphs, there are lots more. You can see that everything is really going off the scale very quickly. So total real gross domestic product, good thing, I guess, for humans. Population is the obvious one, but things like damming of rivers, water use, fertilizer consumption, and the one that always really grabs everybody's attention, I think it's brilliant that he did this, is the spread of McDonald's restaurants. There are 39,000 of them on this planet. There are 19,000 Burger Kings, and a good friend of mine, Jens Elzovich, and I tried to work out their spatial coverage of them on this planet. You could eat McDonald's and Burger King from New York to Chicago if they were all lined up in a row, which again is an amazing figure to think about. And a good example of your and my capacity to alter the Earth system. We are the major geological agents at the surface of this planet. We move much more sediment than all of the Earth's rivers. Again, it's a staggering figure, and you can see the order of magnitude differences here in terms of our ability to terraform the planet. That's vast amounts of water. You saw one of Will Stefan's graphs there. 4,000 cubic kilometers of water every year. That's a figure that I actually can't imagine. So we have to think of something really big, like Lake Malawi in Africa. And that's the equivalent of draining Lake Malawi every 2 years. Or if you want something closer to home, that's the equivalent of draining Loch Ness every few hours. That's the pace of our consumption of fresh water on this planet. It's vast amounts of energy from various different sources, of course, from energy resources, but also, of course, the energy that we extract from the biosphere, which is also considerable. I'm only showing you the primary energy resources there, but you can add more 300 exajoules onto this, all of the other sources of energy from the biosphere that we take as well. So massive amounts of energy consumed, and of course, the pattern here has been an upwards trajectory. Change the atmosphere too. In 2021, we put about 38 billion tons of carbon dioxide into the atmosphere, and of course, that's having an impact on global climate. There's other paleontologists in the room, lots of other paleontologists in the room, but I cannot think of another species with a geological history of this planet that has dominated both the terrestrial realm and the marine realm. If you can think of more, then please tell me. We're unique. We don't just dominate the land, we also dominate the sea. We take millions of fish products from the ocean each year, and we waste about 25% of them. They just simply don't get to be consumed by humans. Then staggering figures, and I think it's important to kind of quantify the Anthropocene at the very start. And then we will get a distinctive geological record, as I hope I'm going to be able to show you as we go through this talk. Again, that's a staggering figure as a result of the Haber-Bosch process and fertilization production in the 20th century. The nutrient cycle on planet Earth by a degree, which is probably the greatest one in 2.5 billion years, which is again pretty staggering for one species to do that. Obviously, we put a considerable amount of carbon dioxide into the atmosphere, and we can measure that because we have fossil evidence of that change, and of methane also, and that's resulted in this more than 1 degree Celsius surface temperature, mean surface temperature rise on this planet, and of course that's now projected to get quite a lot worse. Lots of other figures that I could give you. I started with that picture of plastic, and I mean, it's staggering. 8 billion tons of plastic produced since 1950. Wherever we've looked in our GSSP successions on this planet, and I'll show you the range that we've looked at, we find plastics absolutely everywhere we look. Of course, you know that, we're even in the deep ocean, in deep ocean sediment also. 500 billion tons of concrete, again, staggering amounts. And many other signatures that we get. So we get clear fossil signatures, for example, or geological signatures of pollutants from the burning of hydrocarbons. Again, we can find them even in the Antarctic ice cores. We find evidence of human pollution. Just some figures to start with in terms of thinking about impact on the broader Earth system. But the paleontologists, they also want to emphasize the biosphere as part of this, because that's what I studied, the biosphere over time. What has characterized the biosphere in the Anthropocene? And it was unique in terms of the things that I talked about in the past. From recent reports, if you're looking at the COP meeting in Glasgow, but there's as well as the climate ones now, equivalent biodiversity one, we just reported a few weeks ago. We know that there are 1 million species at risk of extinction, or we think we know. We haven't even quantified the number of species that are living on this planet. Certainly having a significant impact on species extinction. If you Google extinct animals, I think it's an interesting thing to do. You get the big things that you know. Obviously, everybody knows about the dodo. It's a classic example of extinction. Beautiful animal, been since 1952. The beautiful young sea dolphin, not been seen since 2007. Evocative of our impact on the planet. George the Hawaiian tree snail. So for anybody who's heard of George the Hawaiian tree snail, I guarantee everybody's heard of the young sea dolphin in the room, because it made major news media. But George the Hawaiian tree snail, a species of snail that was really important, extinct. Extinct on the 1st of January 2019. Just extinction that was around us on the planet. So let me come back to George the Hawaiian tree snail a little bit later, because I'm going to show you what caused the demise of this snail, actually species of Hawaiian snails. George is part of a much bigger extinction event. If you go to the red list, you'll probably find quite a small number of species really that have been earmarked as gone extinct or in danger of extinction. When you start to interrogate the databases in real detail, you see that actually the extinction that we're in at present is already a significant one. You see there's 13% potentially of mollusks going extinct over the past 500 years or so. So we're already in a significant extinction, if not already in the beginnings of a mass extinction event. Extinction is a big part of the Anthropocene. Some of the people in the Anthropocene working group, like Tom Barnowski, have worked on this for a very long part of their careers. I don't want to talk about extinction so much with you this evening. I am going to talk about it a little bit. The reason being that extinction is only one small part of what human life has been doing biosphere. It's only one component. It's the one that gets the big attention, but it's a much more significant impact. It's amazing. The species halved the mass of this planet over the past 10,000 years. So 10,000 years ago, there was double the mass that there is on this planet at present. And much of that, most of it has been from deforestation, because of course most of the mass of the biosphere is in land-based vegetation. It's a staggering figure to think about. Half the mass of the biosphere is being lost. We've concentrated mass in those things that we like to eat. Again, a staggering figure, originally devised by Václav Smil in the early part of the 21st century, and then by this very good group in Israel that are trying to quantify our impact on the biosphere. But 96% of the terrestrial biomass of mammals is urinary and the things we eat. The rest is 4%, less than 4% actually. Again, that's a staggering figure. I cannot think of a food web that had been so altered by one species that we have evidence for in the geological record. If you can, please tell me, because I think these are unique characteristics of the biosphere that's global in their history on this planet. To change the landscape, another person from the Anthropocene working group, I was at the University of Maryland, trying to quantify the way in which we've anthropocized the landscape and ecosystems around us. What's and if you like, it's a heavily modified. It would be one of the kind of anthromes that would define as being used. So, actually still at 25%. Systems have suggested that as much as 90% of the landscape is impacted by humanity. And so we have to come to a staggering closing of this work and of other people's work. It was now really dominated by natural ecosystems with humans disturbing them. Humans of natural ecosystems. It's kind of wholesale change to this planet, and for me it's reminiscent of some of the really big step changes in deep time. For example, the Great Oxygenation event from 2.5 billion years ago, as when the biosphere starts to be subsumed into another new type of biosphere. And the figures are staggering, but if you look at the way in which we've translated the animals that we like to eat, and the way in which we've modified the land surface, half of the habitable land is used for farming to support us and our animals, and 3/4 of that is for meat and dairy, and about a third of the land that's under crops is also used to feed farm animals. So this is a very marked change to the surface of our planet. We change the organisms within those ecosystems too. So this is what we've done to chickens. This is the Chicken of Tomorrow program, which was banned in USA. Over the past 5 decades, it's increased the individual amounts of chickens fourfold. That's from the perspective of breeding people, but it's a very brutal thing to do to these animals, and they don't have a very good life. They've also left a distinctive fossil record, which I'll come back to a little bit later because of the anatomical changes. It's also smeared on geographical boundaries. So we talked about Alfred Russel Wallace as being one of the major natural scientists of the 19th century in terms of understanding evolution and biogeography, but actually these biogeographical boundaries now are being smeared by the actions of humans. Itself. One of my PhD students, Rachel Holmes, is doing a fantastic job at the moment trying to quantify the degree of homogenization of the flora across the Wallace Strait, and it is definitely homogenizing as a result of human impacts. She's just plotting up the distribution of golden apple snails. Golden apple snails are from Argentina, what on earth are they doing in the rice paddy fields of Southeast Asia? They're rampaging across them now. And we believe a pretty good fossil record because snails don't get preserved in the fossil record. They really couldn't care less about the natural biogeographical boundaries. They're just going straight across them. And that's a phenomenon that we find everywhere on this planet. So that was the Wallace Jail. But if we went to isolated ocean islands, so I'm going to take you a little bit later in this talk, we find evidence for introduced invasive species, and we'll show you how they've then impacted on the indigenous species and how that's actually represented in the fossil record. There's already a clear fossil record of these patterns that have been discerned, not principally by paleontologists, but now very recognizable in the paleontological record. Of course, many of these changes have unfolded over millennia. We as a species have probably been translocating other species for about 20,000 years. There's evidence for that. They've certainly accelerated as we've gone into the 20th century. And as those processes have accelerated, they've left a very distinctive paleontological record that we can recognize across this planet. I talked about polar chickens, a little bit earlier, and I'm going to show you the kind of physical record that you can find of chickens, from archaeological records, and very substantial changes you got into the 20th century. So chicken anatomy is still pretty much the same, even after domestication. Over a very long period of time, chickens have been domesticated for thousands of years. And this is some work done by another PhD student, Klaus Bennett, a few years ago, just looking actually at the changes in their anatomy over time. We see a big jump as you go into the 20th century as a result of that breeding program, the chicken of tomorrow. And if I was a paleontologist looking at these patterns in deep time, I'd probably come up with the name Gigantocalyx for this. And it's so distinctly different. And you think, wow, that looks like a different fossil in the fossil record. Many of these figures are a bit astonishing, and I'm sure you know much of this already, but I think it's important to say this at the start before we start to actually look at the physical geological record of this. Before we look at the physical geological record, I want to ask you something else. I want to ask you, what is driving all of this change? All these patterns of human impact on the planet accelerating so rapidly as we go into the 20th and 21st century. You might know, yes, and really is going to be one component of the technosphere that I'm going to talk about. You may think it's you and me, as a choice and species. Actually, my good friend Peter Hunt, who was another member of the Anthropocene working group, would argue that it's the technosphere. I don't know if you've come across this idea of the technosphere before, if anybody's come across this, but it's one of the major ideas that's now being developed as a driving mechanism for this Anthropocene change, and certainly international finance is a major component of this. What's the technosphere? Just nice definition of this. A little long, so I'm going to see this a little bit, but it's the autonomous. Notice the word autonomous. You are not in control of it. It is the autonomous global system that comprises the humans, technological systems, including the transport networks, communication, etc., associated bureaucracies, military, educational. So it's everything, if you like, that defines humanity, our social connections, our technological connections, our agriculture. You are not in control of this. This is a complex system that is emerging and developing and is evolving in its own trajectory. We can't control it. We can't stop it. We can stop it. If we pull the plug out, it's this too much, right? It's no balance on this planet. So it's got a really strong point here. And actually, you can see that in the systems of the technosphere. There is, yes, we've already been talking about their impact. The movement of iron ore, oil, cement, coal, aluminium, all these other commodities, finance, there's many across the globe. This is the global system that Peter defines as the technosphere. And it is completely out of our control, and it evolves in a completely different way from the kind of other components of the Earth system. And so there's definitely a sphere. It's like the atmosphere, the hydrosphere, the biosphere, the geosphere. It is everywhere at the surface of our planet. And plastics in the deep ocean, for example, wherever you go, we find evidence of the technosphere and of its influence. Remember, the technosphere has it co-evolved with those other components of the Earth system in a way which nurtures a habitable state on this planet. And the technosphere actually is operating to degrade those other systems. Out of control, if you like. But just like our water, selling food, we need technology to sustain us. We couldn't be having this conversation without technology. We wouldn't be sitting in this room. And that's a problem that I want to come back to a little bit later as we go through this talk. Next, its waste products. Again, a few years back, we tried to measure it. 20 trillion tons, that is, it weighs more than the mass of the biosphere, if you take all the different components of the technosphere. So we've argued it's a bit like an engine on a car that's accelerating, that's out of control. It's spinning away, and at the moment we have very little control over it. One possibility then is that it spins away out of control until the wheels fall off, which is bad for you and me, bad for the technosphere too, but it's bad for you and me. I'm going to park the technosphere for a moment, and I'm going to come back to the technosphere a little bit later. I wanted to say the scenes of the technosphere at this stage, but I'm just going to stick with that for a moment and come back to the geology. Try and keep the technosphere in there. Hopefully you agree with this that the human impact is ginormous. It's like a ginormous physical record that geologists can recognise, just as we can recognise changes at the Triassic-Jurassic boundary or the Cretaceous-Paleogene boundary. I want to show you how we might define the Anthropocene. I want to show you how paleontology plays a role here. So this is the geological timescale. It is our contribution to science. The geologists may think it is going to explain how the Earth system on planet Earth has evolved over 4 billion years. And of course, for us to understand all of this evolution, we have to have a kind of framework, a language whereby if I'm talking about the Paleogene here, somebody in China knows that's the Paleogene too, somebody in Indonesia knows that's the Paleogene, and so on and so on. What we've established is this international time scale with its various geological boundaries. Those geological boundaries need to be as possible. When we define the boundary, we need to recognize a symbol everywhere around the world. It's essential, of course, because if we can't do that, we need to correlate all over the place, and that means we're not going to be able to understand how the system has evolved over that time frame. So this community is really essential when you're trying to define a geological boundary. Changed. So this best example from 66 million years ago, because it can be traced around the planet, and of course it's associated with a instantaneous physical impact, and it can be traced very precisely because of that. We need something like that for the Anthropocene too. The question is that when did humans overwhelm the Earth system? And what is the geological record of that? Where is it the best place to define the boundary between the Holocene and the Anthropocene? Of course, we as a species, as a group of species, have been around for a long time. And that means we need to look at a whole range of different processes if we're going to think about our impact, and also about how we might define the geological boundary. And that means we've got to look at things like hunting and gathering, because that has an impact on the biosphere. Scope investigation, most definitely. Section growth. Let's just have a look at these 3 different human processes and see what kind of physical stratigraphical signal they've left in the geological record. Many of them need a kind of paleontological signature that we might use to define the Ordovician Silurian boundary, for example, as it is in Dobslin in the submountains of Scotland. Let's begin with hunting and gathering then. It goes back as long as we go back, so it goes back 3 million years of human evolution. And before that, of course, also with Australopithecines. You can certainly see a very distinctive signature of hunting and gathering in the physical stratigraphical record from about 50,000 years ago. And a component of these so-called megafauna extinctions, a loss of large mammals and birds, and animals of 44 kilograms weight or greater. So obviously our record of hunting and gathering goes back a long way. Species. So humans and maybe the we have so we go back in depictions of Kengar, for example, from about 40,000 years ago, from Indonesia to Europe. The time that we appear to be sense that very sophisticated stone toolkits, impacts start to become clearer in the geological record, particularly in those parts of the earth where Homo sapiens are the first human species in the landscape. So in places like Australasia and in the Americas, as we enter these regions, for example, ghosts in the Americas when humans arrive. And humans are almost certainly implicated in this. The change may be part of it, but humanity is also playing a role here. And here we can see the signature around the world, as I said, in those places where Homo sapiens are the first human species in the landscape, the megafauna extinctions are much more profound in the Americas and in Australasia, but also in many other regions of the world. And that's left a distinctive fossil signature that we can recognize in many different places on this planet. You can use it to define Anthropocene, because it's still taking place at present. We're still causing the demise of large animals, even in the present. So this doesn't work. Gathering is totally transgressive. It doesn't give us a synchronicity signal that we need to define a geological boundary. It is a profound importance in terms of your and my impact on the planet, that we can use this to define a geological boundary. Landscape domestication then. Most people would take that back about 13,000 years, including in places like the Eastern Mediterranean. So humans were practicing a developing agriculture much earlier than that, because in the same region, in the Levant, there seems to be evidence for kind of trial cultivation of crops going back perhaps 23,000 years. So just like an impact on the megafauna, this process of landscape domestication is unfolding in a complex way over a long period of time. It's multipolar in its origin. Of course, we have at least three different major centres of agricultural development in the Americas and Africa, Asia, and in the Far East also. Each characterized by its own history, and each characterized by a distinctive set of crops that leave a distinctive fossil signature. Fossil signature. We can always see that. It's a profound importance, of course, in the way in which we've domesticated the landscape around us. And that unfolds over thousands of years, and of course, is still unfolding at present. Distinctive fossil signature for sure, but not one that we can use to define a geological boundary. But nevertheless, important to understand in the context of the Anthropocene. What about globalization then? And arbitrarily, this is a chose with the other ones, we'll take 1500 CE as our example, because that's the date of the Penguin exchange between the old world of the Americas and the old world of Eurasia. It's arbitrary too, because people were exchanging goods across the Indian Ocean thousands of years before this. Goods, things were traveling on the Silk Road. This is a complex process of human impacts on the planet. But we took the Columbian exchange as our start point here, and we examine if that's got a fossil signature too. It definitely does have. So one of the things that gets moved around the planet is exchanges. It gets transported everywhere around the planet. Something like a distance, it's a signature. It's a signature of the exchange. So we go to something next, like fossil signature in the African lake of the carbon exchange from impacts on the planet. So, because clay pipes is the pollen of tobacco. That's a fossil signature of the carbon exchange. It might be a very unusual taxonomic setting, but nevertheless, that is a fossil signature of the carbon exchange. In cesspit, in Rembrandt's ice, in the 17th century. Problem, of course, with those fossil signatures is just like the other signatures of landscape domestication and of megafauna extinctions. This is a time transgressive process. It's unfolding over hundreds of years. There's nothing that gives us that synchronicity in these older signals of globalization. So the new signal, for example, differs in lots of different places as you go around the world in terms of where you pick up the first signature. But one way to define the Anthropocene doesn't give us that isochronous boundary, but it's of course of profound importance in terms of our impact on the planet. But we can find a signature, a fossil signature, that's isochronous, present in the 20th century of globalization. And it also dovetails with a whole series of other parameters of this great acceleration in the 20th century when humans began to overwhelm the whole system. So, signatures that you can find is the progressive homogenization of fauna and flora on the planet. This is a great body of work being produced by Hans Siebens and collaborators at Senckenberg in Frankfurt. And what Siebens and others are doing here is actually just looking at the way in which organisms are being translocated by humans across the planet. So it's a long period of time. It's extended over the past 2 centuries. And there's been further acceleration as we've gone into the later part of the 20th century. And it's important because when we get into the 20th century, so this is some of the work we've been doing as part of the Anthropocene Working Group, we can start to find species which are translocated across the planet almost instantaneously. That means you can start to build chains of correlation across the planet that will tell you that's 1980, that's 1950. And it's amazing that you can do it. And in a moment, I'm going to show you a specific place on planet Earth where you can do this. In the 20th century, we can find very narrow intervals of time translocation of organisms across this planet. And that dovetails with a whole series of other stratigraphical parameters that we can find on this planet. So, there's an Anglo-Saxon church near to where I live in Northamptonshire from the 9th century, and bottom left is a temple from 9th century Southern Vietnam. It is London. Bottom right is Ho Chi Minh City. But you know, if you're an alien species landing on this planet, you have real problems differentiating those two. You get those two as being different straight away. The biogeography of cities is now homogenizing too. And of course, the things that are made from are also homogenizing too. Because these are made from steel, plastic, glass, and concrete. So this is not just an homogenization of the biosphere, it's even an homogenization of the biogeography of humans in this sense, that leaves a stratigraphical signal. Sticks, for example. That dovetails with another profound signal of humanity in the 20th century, a terrible one, of course, but the detonation of atomic bombs In the 1940s through into the 1960s, has left a distinctive signal, stratigraphical signal that we can find everywhere we look on the planet, with a very distinctive topology of the beginnings of the urban tests rising to a peak and then dropping off. It gives us a very clear stratigraphical signal in the sedimentary record. How do we know that? Because even just up the road from our work at Leicester University, what he talked about in the Anthropocene at all. A single mention of the Anthropocene in this PhD thesis. But this is a course, as you can you can see the cesium spike. Now, cesium spike is the 1960s proliferation of odontes on this planet. And you can find that wherever we go on the planet. And it's also been recognized in Scottish lochs and lakes as well. Everywhere you look, it's found. If you're wondering what the second spike is, that's Chernobyl. Everywhere you look, we find this. Okay, that's a kind of theoretical discussion. What about on the ground? Can I take you to somewhere on planet Earth and show you how the fossil signature of human impact manifests in the physical stratigraphical record? Because if I can't do that, I can't demonstrate to you that there was an Anthropocene. So I am going to do that. Some of the different places that we're looking at as an Anthropocene research group, and these are the sites that we're voting on at present. I can give you the details of the sites, because if I do that, I completely destroy the entire voting process. And I can take you to one of those sites. I'm going to take you to San Francisco Bay, because that's one of the sites that many students have been involved in. So let's go and look at San Francisco Bay. So David worked in San Francisco, so where David's gone now. But you perhaps didn't realise that the bay there is fundamentally changed from the state before Europeans arrived. Fundamentally changed. I'm going to show you how that's so. You've been to San Francisco, fantastic city to visit. And this is very much the work of a great PhD student called Stephen Hudson, who's just got his PhD. San Francisco is an important place in the Pacific because it's one of the major hubs for trade. If you look, it's one of the major nodal points of the technosphere. This is where the technosphere is operating at its kind of maximum. And just to show you that, and just to show you the influence of the technosphere, this is a great website that you can go to where you can watch international shipping as it's actually moving around the planet. This is just one download from that site. You can see it's just absolutely profound. This is the movements of goods around our planet. Again, these are the arterial flows of the technosphere, and San Francisco Bay is sitting on one of these nodal points in the technosphere. As a result, sometimes deliberately, but not generally in the case in San Francisco Bay, have introduced a huge number of species into the bay, accidentally, if you like. This is a very important work, published a couple of decades ago now, but still very, very relevant here. You can see, since 1850, 134 introduced species recorded in the bay. It's actually more now because we've found more as part of the work that we've been doing. And next to those, I've occurred quite recently. That fits with the global picture that I showed you earlier. And this is the one we want to notice. Non-native organisms in San Francisco Bay account for 97% of the numerical abundance of organisms. 9% of the populace. This is because we have Berkeley, Stanford, University of California, the United States Geological Survey, in this region, examining this. Places on the planet that are like this now. Students doing this in Leicestershire, which is what Simon was referring to at the start, trying to look for the same kind of signals and finding them. Let me just show you what happens when the American arrives in the middle of the 20th century. Obviously, the American is not native to San Francisco Bay. And it proliferates with some invading. This is an invasive species. We've raised to 2,000 individuals per square metre, which leaves almost no space for the indigenous molluscs. It's an invasive species. And of course, because it's a mollusk with a shell, it's going to leave a fossil record. So we've gone into San Francisco Bay with some very good colleagues from the United States Geological Survey, especially Mary McGann there, and we went to what we called in the bay. And we made a whole series of new cores, and we also looked at pre-existing cores in the bay. And what we're trying to do now is to see if we can recognize that observed record of change actually preserving in the physical record in the bay. That's exactly what we found. Let me show you here some of the things that start to the various cores that it's looking at. So everybody, the two instruments, stations, station, in San Francisco. Nobody would recognize it in San Francisco until we had a record, just because they're tiny. This one they do, I've noticed, that's a fairly amoeba. So a unicellular amoeba-like organism with a shell. That's called Anthropocene heyday, and that lives in the seas around Japan. It has no right to be in San Francisco Bay. And just a good measure, on the right-hand side, you have the mollusk. The overall climb. Station in San Francisco Bay. It's invasive. Let's have a look at that. Show you the clams. Let me show you this. So, 1986. That's from observational data, and then it proliferated, as you can see, 1,000 individuals per square metre after a couple of years, and then now, after a few years, 1,000 individuals per square metre. That's invasive. That leaves nothing for the indigenous fauna whatsoever. It just eats everything that's available in the water column. What a good thing to have on San Francisco Bay. And this phenomena has done the same kind of thing. It was arrived in 1983. Was a freedom excavator, and that's been done since the Pleistocene. But it's been replaced largely by Anthropocene, which is a dominant family. So this is a competitive replacement of one species and another. A clear fossil record. The fossil record is amazing. He's a great PhD student who does a super job. This is one of his cores, which you can go back to 1952, because of course we're looking for this Anthropocene boundary. And what is shown here are the red introduced species. And we know when some of these were introduced from observational data. And this is the really good thing about Stephen's work. So when in 1975, that's when the ostracods arrived from East Asia. And then in 1983, that's when that Palaeontological arrives from Japan. 1986 is when that clan arrives from East Asia. And the thing I want you to notice is, this is the sediment core, moving in the correct stratigraphical order in the sediment core. So we're replicating a really precise stratigraphy of the arrival time of these species into the bay. Of course, we have lots of other data that we use to reconstruct the age of the sadly, that's mercury contamination in the bay from mining. And the other one we know is mid-1960s, the radiogenic signals, which are very, very complex in San Francisco Bay. Those of you who worked in the oil industry, and certainly are some of you here, you probably know about ranking and scaling as a tool which is widely to correlate. Stephen again being such a good PhD student, his paper in preparation this time, then took all the stratigraphical data across the whole bay, 20 different cores, and was able to scale the past 70 years. And subdivided it into 7 zones which you can correlate across the bay. And this is the kind of thing that you might think you can do in the Cretaceous or the Silurian. Stephen's done it for the last 70 years in San Francisco Bay in the stratigraphical data. Exactly works just like it would in the Silurian. The Anthropocene starts to look just like other geological subdivisions of time. It's just in a much narrower time frame. That's important of itself, I hope, that you can see. But that's just one place. How do we correlate the Anthropocene to the 20th century to demonstrate the late part of the 20th century paleontologically again? I can do this, we can do this. We can go back to the UK actually if we need to. Let's go to a whale though, because that will cross 4,000 kilometers. And we know that the highlands are heavily invaded. But you can see now the figures, again, a classic paper from a couple of decades ago quantifying this. Because this is a remote place, it's been visited by humans for about 1,000 years. Humans have translocated organisms being in the Pacific rat bar about 1,000 years ago. And there's a fossil record of Pacific rats being introduced to the environment in the Netherlands. During the 20th century, introduced the giant African snail. Why would you introduce the giant African snail to the Rhine Islands? Then to control the spread of things like the giant African snail, we think it would be a good idea to introduce the cannibal snail. And the cannibal snail does exactly what it says on the tin. It eats other snails. And in fact, the cannibal snail is implicated in the demise of George the snail, who I showed you right at the start of the talk. So trying to link those two different components. It's left a record. Again, it's not a classic study done really before we were talking about the Anthropocene. This is one of the major sinkhole successions that you get on Kauai, one of the Hawaiian Islands. And David colleagues has plotted up a fossil record of snails in that sinkhole. And at the bottom of that sinkhole, you have the fossil record of all of the indigenous snails. And on the top, from the 1950s onwards, all the indigenous snails vanished because they've all gone extinct, they've all been extirpated. And what do you find? The giant African snail and the cannibal snail. So there's the Anthropocene again. And the Anthropocene can be clearly identified paleontologically and correlated back to San Francisco Bay and to many other places around the planet. In fact, I can't give you the data, but I can tell you that sites from San Francisco Bay through Seasville Reservoir, through to Crawford Lake actually, and here into a Polish peat bog, into a Chinese lake and a Japanese bay, show a paleontological signal of the Anthropocene. They will show those other signals too, water contamination, radiogenic spikes, spherical carbonaceous particles, to you can find spherical carbonaceous particles. Marker of these huge changes to the biosphere and the Earth system, so a marker of the Anthropocene. And then again, I wanted to finish with some polemic, because I think it's important to inject a bit of polemic into this discussion and diverge a bit away from the paleontology and the geology and talk a bit more about what we're doing to the planet. And to come back to the technosphere, because I think Peter have said of the technosphere a really good way of synthesizing the way in which these processes appear to control, to direct control. The process is that the technosphere does indeed appear to be overwhelming the other components of the biosphere, the other components of the Earth system. What we also know is that the technosphere is a unique component of the Earth system. There's never been a technosphere in the past. There isn't a technosphere of Atlantis, as some people want to suggest. This is a unique component that's grown particularly in the 20th century. It's left a very distinctive signal, which I hope I've demonstrated to you. So for me as a paleontologist, for all of us as geologists and paleontologists, what that process signal shows is an unprecedented change to the Earth system. It's never been anything like this before. It gives a fossil record that shows a signal of translocation like this on a geological record. It shows an irreversible change because these are not irreversible changes. You can't take San Francisco Bay back to what it was like before. It's just not possible. And it also shows, as I hope I've demonstrated clearly to you, that this is an accelerating process. And that's important because all of these can be measured versus what we can see with paleontological change in deep time. Because there's a kind of comparison that we can think about. And that means as geologists, we can start to think about what the real future outcomes of this change are. Okay, changes carry on with the same trajectory as present. Unsustainable technosphere overwhelms the Earth system, big mass extinction, fantastic marker for me and Neil, and anybody else who's a paleontologist and the audience, a disaster for the Earth system, of course. But that's obviously a strong likelihood if we carry on with this trajectory. Second one is that just like the other components of the Earth system, the biosphere, atmosphere, hydrosphere, and geosphere, we need to be, as far as we can, a naturalistic state of the system. It's not just a technological solution, it's actually change human interact with the rest of the system. Was acting effectively. One of the two of us can't make a difference, but one of us can make a difference. Starts to question some of the models we talked about earlier on, some of the models that we are being built for solutions to the global problems. See, a diesel and a petrol car with an electric car will not solve the problem. It's replacing one form of consumption with another to the same outcome. Fantastic. It's got a really good underground civil system, yes. And it's going to be developed, as I was reading about it, which also sounds really good. But to understand Peter's ideas of the technosphere correctly, and this is a process that is accelerating, all technological solutions to some degree will be co-opted by the technosphere. And be really careful how we do this. Instead, we'll just look at the cup, and it would be interesting if those green spaces were much more usable for the other components of the system and biosphere, not just humans. It's not really radical, I think, and really beyond the way that we are thinking at present. And that reminds us, any historians of the Far East in the room, any historians of Japan? I've been thinking to work with a colleague called Julia Thomas at Notre Dame University in the USA, and Julia explained Japanese civilization and examples of humans interacting quite well with the rest of the Earth system. Talking about Japan, in a period when Japan is closed to the outside world, it's good mutualistic meaning of the Earth system around it. And that's because it was a closed society, so it couldn't import things. As a result of that, there were whole artisan trades to repair pottery, to repair metals, to repair clothing, recycling. Again, if you've traveled to Japan, you'll know that the repair of pottery is held in high esteem in Japan. A repaired pot can be more valuable than a pot if it's damaged. Also, we were extremely good at recycling waste. So, Udo, the precursor of Tokyo, all of the human soil was recycled into agriculture. So, there are good examples of how we have been able to do this and to collectively have an impact on the world around us. It's not a panacea because it was hierarchical, it was brutal to people lower down in society. There are some good things that we can learn from Tokugawa, Japan. We can slow the pace of consumption of the technosphere, if we think that's a good concept, and we can steer it towards a more mutual relationship with the rest of the Earth system, and it might start to be more like the interaction of the other components of the Earth system. And that might buy us time to stop a catastrophe. I'm going to my last slide. I'm finished with the polemic now. I hope I've demonstrated to you that there is an Anthropocene, that the changes that have occurred in the century are much greater than anything that's happened before. It's a distinctive geological signature, recognized by the future. Demonstrating accelerating patterns of the text. We're going to accelerate to a stage where it's extinction. And I think think that palaeontological signal is absolutely unique. I don't think we can see a palaeontological signal anywhere in the geological record like the one that is unfolding at present. And I think that geology and paleontology therefore has a lot to contribute to the debate about how we're changing the Earth system because of the uniqueness, because it's defining a pattern which is accelerating and out of control. But also because we're all Earth system scientists, and we understand that if these different processes can interact in a beneficial way, then this can be a habitable planet hundreds of millions of years into the future. Thank you very much for listening to me.
Thanks very much. Thanks very much, Mark. Mark will have noticed that I had a pizza the size of a tractor wheel in the restaurant before we came here. And so I was quite worried about whether I could stay awake through all of that. But you had me absolutely gripped all the way through. There was no need to worry. So I'll open the hall for questions.
We just did take a microphone so that the audience will hear your voice. Yeah.
When you look at the reality, you can take Glasgow, alcoholics, drug addiction, poverty, no employment, lack of money and so forth. You have a situation with politics, you have a situation with finances. The world is, you know, the West is affluent, the East is not so affluent. So I think you're not taking that on board. And also, just add also an extra thing. When you look at the cars though, you're talking about the cars, the diesel and the petrol. But one day, you never know, we might have airborne cars. You know, there's a vision there of a technological change. 100 years ago, it was just horses and carts. Now we're looking at the sophisticated cars we have now. So, you know, 100 years from now, what have we got? Airborne or airborne way of traveling? Who knows?
Well, I need to use that, or can I just? Yeah, okay, so you're absolutely right, and of course, me as an individual can do very little. But I can come and talk to you and hopefully get you to think about these ideas. And 2 decades ago, and Neil will know because I worked with Neil, because I worked with the Geological Society and the Southern Uplands, I was collecting graptolites to try and define the Southern Uplands accretionary prism complex, which I loved. I absolutely loved it. And now I'm talking to people in the business community about how they redefine business models to become completely circular. So I agree with you, it's very difficult when you look at the huge amount of change, the huge amount of problems around us. But I think one thing that has changed very distinctly in 2 days is the multidisciplinary nature of the way in which we interact. So we're looking at a whole series of business models that are predicated on longer cycles rather than short-term financial cycles. And we've been writing all sorts of research papers on this, and we seem to be getting some influence. And that wouldn't have happened 2 decades ago, because a geologist would never have spoken to somebody in the business community. And no one in the business community would have spoken to geologists. They might have in large corporations, I guess, that could maybe do something geological. So I think that partly answers your first question, or at least it's going in that direction to show you that there are potential dialogues that can start to think about solving a whole plethora of those problems. And of course, thinking about cities and the way in which they function, you're absolutely right, the huge disparities of wealth on them, but there's a whole group of people that city should be decided much more futuristic. You probably know Kate Ralph's work on donut economics and donut cities and things like that. So we're trying to go in that direction. The influence is still slow, but the alternative is we do nothing. And if we do nothing, the chancellor will do exactly what I told you there. You talk about technological solutions as potential fix. I don't disagree with that. I think the technology has a role to play. So I think if we could so obviously, using renewable energy sources is a good way to go. Although it's not entirely renewable, of course, because it still needs materials. But it might give us the time to get us towards a state which is less damaging and more beneficial to the system. So, who does? I do, and that's what really worries me. because I do not want that kind of situation for my daughter. And so, I mean, you know, did the ending of Blade Runner, the original Blade Runner was set in 2019. And Los Angeles was supposed to have 150 million people in it. And the film, which is great, yes. So if you look at projected city growth for the 21st century, there are some cities that are projected to be Blade Runner like Los Angeles cities, Lagos, 21st century. How can it possibly function in its present form? Or how can a city like Glasgow possibly function in its present form and not destroy the ecologies around it globally? Because they're centres of massive consumption at present. You can act individually. So I don't that one of the things I often talk about, you should know lots of simple solutions that you can do. Consumption, so distributed that change in consumption is driving a lot of the degradation of the land that is needed to produce the meat. So, but again, I haven't had those conversations 20 years ago, but I know I've been conversations with people who have some influence in those domains. So I think geology does have quite a strong role to play here. It's no passive solution. I do think if we're driving around in cars that are flying over there, that's going to have massive energy consumption. What will the telescope do to that? It can limit it. Yeah, but the telescope will limit it. Go up to it, and it will just engender even more consumption. Yeah. I agree. So that's why it's so important that scientists are part of this debate. Because if anybody understands how the Earth system works on this planet, it is us. Because we have a full record of how it functions well. And so I think we have a really strong role to play here. So sounds like education of the human impact that and the business community of them.
You have a question.
Well, I have to say that was a really fantastically enthralling talk, and I can tell you so because I wasn't trying to nod off in the middle of it. Anyway, the point I would like to make back to the human population. Now, during the COVID crisis, in many cases on radio and what have you, there were people who came on with a question saying, this is the human population that's exploding out of control, and it was immediately shut down by every single presenter that I heard. So my question to you basically is, what's the answer to that? Is it to shut down the pharmaceutical companies so people get diseases? Or what is your answer to the human population, which is fundamental to everything that you have said in terms of degradation?
Yes. So this it's fundamental. It's extraordinarily over consumption again. We're converting about 50 kilos of steak every year. It's a mental impact because I'm sure you know about the loss of energy at different stages in the food chain. So that by the time you're eating a cow, you've lost 90% of the energy that it was consuming from plants. So that in itself is a way in which that kind of consumption can do real damage. Now, if we're 8 billion people on the planet consumed the amount of meat that an Argentinian does or an Australian does, we'll be in a really bad situation now. And we'd be talking about 50% loss of mass with the biosphere, we'd be talking about 75% loss. And that thing has to be avoided. If you're eating a diet like somebody in South Asia, impact on the Earth system. And I showed you the figures about 50% of the habitable land will be converted to farming. 75% of that is supporting animals. That's an inefficient way of moving energy through the food chain. And most of that consumption, or the bulk of it, is in wealthy Western countries. So it is not population per se that is the problem. It is the unequal distribution of wealth across that population. Population problem appears to be solving itself in that now, because of the emancipation of women in places where they've not been emancipated, the birth rate is dropping very, very rapidly. So it's very likely that the human population will peak around about 9.8 to 10 billion in the middle part of this century. That's silly not. It's not sustain that population, people, and do a lot less damage to the planet if you change your patterns of consumption. That's the point to make. It's not about population per se, it's about the way in which different components of humanity consume at excessive rates. That's the problem.
Right?
Yep.
Every part increases its well, wants to consume more of the meat that we're talking about.
Yep.
The other side of the equation is what can you actually grow in certain parts of the country. So in Scotland, for example, their ability to have arable farming, to say cereals or something like that, is limited to certain small areas. Many of the other areas will only produce grass, and the only consumer of the grass is the livestock, sheep or cattle.
I absolutely agree with you. I can't in a 1 hour talk go into the granularity of farming systems on planet Earth. And absolutely, this cannot be a one size fits all. The one size fits all model is the model which is doing all the damage, you know, because I showed you Ho Chi Minh City and I showed you London, and they're operating on similar models of how you design a city in completely different biomes, in completely different climate zones. It doesn't work. So I'm not trying to say that everybody in Scotland suddenly converts their diet, you know, but it has to be at a local scale. I also understand that. But I can't go into that granularity in an hour. But I completely agree with you in terms of that complexity. There's no simple solution to any of this. But what I can show you, or at least what I can synthesize, is the global patterns and how they are dangerous. I think, yeah, of course. So again, I can't. I'm not Messiah. I can't give you a panacea solution to everything. But well, I think again, that's, you know, I think I agree with you. The problems are profound. So what do? We either do something or we do nothing, and we have to try and do something. And what I have seen very clearly over the past decade or so is that the solutions are becoming multidisciplinary, and people are talking across disciplines, and I think that will have a big impact and will help. But for sure, yeah, I know. Yeah, I can't do that, can I? Obviously, but I can get you to think about how you consume as an individual, and then if you all go away and consume less, you'll have an impact. And if you tell your neighbour to do that, and if you try to lobby people who've got power to think about these aspects, then you're in a better situation in Scotland than we are in England.
I'll have to come to the hub later. But Bob, first of all, you had a question.
So slightly change the tack really, but to bring it into almost a geological perspective and go into our time capsule and come 10 million years from hence. I'm not quite clear what markers we would use in the same way as we've used, because to me, the definition, yes, a lot of what you said is important, but the key question to me is what marker species or what marker artifact would you actually, does it seem at this point, would be the best marker of saying there has been a change? There's no human beings, there's no historical record. All we have are the buildings, the fossils, and so on.
So it's a great question. So the best signature you can find, and we can find it everywhere we look, is the radiogenic signature. It's everywhere, and that radiogenic signature will last about 100,000 years. So because of the half-life of the radiogenic isotopes. Now you can argue, that if an intelligent species comes back 10 million years hence, won't see that because that will have decayed. But it will see a lot of the other signals will still be there, and my fossil signal will definitely be there as long as those sedimentary basins are preserved, and that will be a profoundly odd signature. I mean, say you're a paleontologist and you're working through the succession in Japan, and you go back to the Pliocene and you can find all these mollusks and forams, and they've got a clear stratigraphic record, and then there's another paleontologist working in San Francisco Bay, then suddenly turns up all these things appearing at one level in the stratigraphical record with no prior record whatsoever. That's weird, yes? That's a very odd paleontological signal. And that's not just one, that's many around the planet. That will preserve long into the future. Some of the other signals will too. So the spherical carbonaceous particles, I mean, if you wanted an analogy, palynology, hundreds of millions of years, still be there. Distinctive signal of the 20th century. So it will be there. You and I would be able to see it as geologists 10 million years hence.
Campbell.
Could I ask two quick questions about your theme about the accelerating pace of the technosphere? The first one's a trivial one, and the second one is hopefully less trivial. The first one's about your chicken. I don't recognize the 4-kilogram chicken. I was wondering what the point was that you were making there. I can't go into Sainsbury's and get that. So to ask what was it wasn't recognizable. Could you explain that one?
Yeah.
And the second point, a bit more fundamental. It might be interesting to put on your chart with loads of accelerating graphs the pace of the rate of change of science degrees.
Yeah.
And to question whether these degrees are sufficiently aligned with humankind's future.
I mean, first one is an easy one to answer. If you go to the supermarket and you pull down your plastic packed chicken, that's unless it says free range on it, it will have been a broiler chicken. It will be part of that chicken of tomorrow breeding program, or the results of it will be. That chicken will have lived for 6 weeks, and it will have grown from egg to that big chicken in 6 weeks. And if you can't get a 4-kilo one, okay, I understand that. But these are the massive chickens that are eaten on this planet. And I didn't give you this figure, but I'm going to give it you now. There are 63 billion broiler chickens eaten by humans every year. 63 billion. There are 21 billion broiler chickens alive on this planet today. And the next most populous bird is the red-billed Kalia, beautiful little bird, it's only about that big in Africa, 1.5 billion. It's tiny, so its biomass is vastly smaller. That's a human impact, and it is those chickens you take from the shelf, plastic wrapped. Yeah, it's the chickens that the chickens. The trouble is, if I reel off figures for some of the other groups, they're just as bad. So, yeah, and the bones and yeah, absolutely right. Yes, yeah, but most of those chickens, the ones that don't have free range on them, are broiler chickens. The Chicken of Tomorrow breeding program that started in the USA and then it's actually spread out across the world now. Again, I don't know. I'm sure lots of you have travelled in the Far East. My wife's from the Far East. Wherever chickens in the Far East look radically different from a broiler chicken because that's where they evolved. It's the red jungle fowl. It's a beautiful bird. It lives for between 8 and 14 years in the wild. And it's just, they have magnificent plumage, look nothing like a broiler chicken. Those broilers have lived for 6 weeks in the most appalling conditions. And if you wanted a better example of our interaction with the biosphere, the broiler chicken is a good one. It just shows how far detached and removed from the reality of the Earth system around us we are. And that's the real danger. Don't come on. I can't solve every problem.
You might argue that actually
there was-
the chickens that have been the success because they've grown enormously and they've done very well out of humans. So maybe the chickens are in charge.
Well, but I don't think any of us would want to exchange our lives with those of a brother.
But anyway, there was an educational question.
There was a set. Sorry, so again, I can't answer that. I don't have the expertise. Yeah.
Yes, behind it is a serious question. If you don't align education in any way, let's just say it's free for all, then absolutely you will get a technosphere that will learn whatever they want to learn or be taught whatever universities want to teach them. I'm not saying it should all be controlled, but I'm just saying it'd be interesting to draft it.
Yes, and some disciplines have clearly contributed to the development of the technosphere. I mean, many of the prevailing economic models of the mid to late 20th century are actually proving to be a disaster because they are predicated on infinite resources, which we as scientists know is a complete load of. I won't use the word. And that's ridiculous. That's another example of the complete disconnect between one discipline and another. An economist sits down with a geologist within 5 minutes. They would know that this is not possible, but it didn't happen in the past. And that's why we've got some of these inadequate models for how we interact with the rest of the Earth system. Sorry if there are any economists in the room.
The expanding economy, isn't it?
Yes, the idea of infinite growth. Yes, you're right. A continual growth. Yeah. Yeah.
Mark, in the early stage of your presentation, you characterized cities, and they were values. It seems to me that if we're 8 billion people and rising to 10 billion, then aren't cities going to be more resource efficient way of catering for them people than scattered over the countryside?
Yes, that's a great question. It's really good. And there have been a lot of arguments about the way in which cities should potentially be able to function as entities in the broader Earth system to be much more efficient in terms of the way in which they utilize and use resources. The problem is that actually the opposite seems to be happening. And again, you can see why that is all around you is because cities are the engine points, the focal points of the technosphere, where all the finances is concentrated, where all the consumer goods are concentrated. If you walk down a shopping street, you are bombarded with consumer goods from every side, so you are encouraged to buy those goods. What happens, in fact, is that when we move into cities, we seem to be consuming more, not less. That doesn't mean that the underlying premise of your question is wrong. I completely agree with you. If you could design cities to be much more mutualistic with the environment around them, then that would be one way potentially to solve this problem. So I'll give you an example of that. Movement of people from the countryside into cities. You think about the plumbing systems in cities. In a city like Glasgow, it will be enormously wasteful. I don't care what the water companies might have done in the city or what you may have done as individuals. How many of you have flushed the toilet today? Yeah, me too. Okay. When you flush the toilet, how many of you have got systems in your house where the toilet bowl recycles water from the sink into the toilet bowl? Anybody put their hand up here? Such systems do exist. And actually, if we could bring them into a city like this, it would have a massive impact on the way that we utilize water. But that for me is one classic example to give to you of just how the concentration of people in cities doesn't necessarily reduce consumption. It actually accelerates it because you have to pump the water in over long distances sometimes, and the figures are staggering. I'll give you some of the figures. This is the problem of asking somebody who deals with the Anthropocene. If you look at the cities like Glasgow, so large cities, over 700,000 people, globally, they pump 184 cubic kilometers of water across the planet, sourced from 2/5 of the surface of the planet. They pump the water in. The water is used in a very inefficient way. The water in your toilet bowl is potable water. You wouldn't want to drink it, but you can drink it. And then it's pumped out and treated somewhere else. It's a highly inefficient system. It's not, so in Glasgow, you've got me going, I'm on a diatribe now, sorry about this, but in Glasgow, how many of the buildings collect and utilize the water that falls on the city? There's a vast amount of water falling out there. How much of that is utilized? None of it is. Yeah. 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 Yeah, absolutely. But I've never said to you that I wanted a one size fits all. Absolutely. I mean, I agree with you completely. So let's follow that point. So I can keep going with the different examples of how cities. I mean, concrete is another one. I'll come to that question in a moment if I can, if we've got time to do it, because I'm conscious that.
Getting a bit short, but
So a quick one on another quick example of consumption. So the movement of people from the countryside into the cities of China. And the construction of buildings in Chinese cities uses more concrete every couple of years than the United States used in the 20th century. That's another example of the way in which patterns of consumption are actually accelerating as people move into cities, not decelerating. So it's not happening, but it could be an answer if cities were redesigned. Have a look at Kate Raworth's donut economics model applied to cities. It's really good. It's really good. With Kate Raworth, she's Sophie Raworth's sister. Sophie Raworth, the BBC newsreader. She's at Cambridge University. Really good work. That's one potential solution. I agree with you completely, which is why you don't have one size fits all. I'm saying it comes down to thinking, it comes down to reconnecting yourself with the Earth system around you. I mean, well, okay, I agree with you, but let's just take that one very quickly. Why would you build Las Vegas in the Mojave Desert in the way that you've built it? It's the most ridiculous bloody construction. Sorry for swearing. I get quite angry when I think about it. You build a huge dam, the Hoover Dam, to supply the city with water. Much of the water is just leaked away or used on golf courses or whatever. If you'd gone into that environment and looked at the way organisms operate in that environment, you might have thought about redesigning the city in a different way. And I'll give you an example. It's worth Googling. It's a beautiful desert plant called the ocotillo. It's Ocotillo. It lives in the Mojave Desert and it lives in a really good way. It's got a wide root system for collecting water when it comes in. It drops its leaves when it gets into drought conditions, but it still photosynthesizes through its stem. It flowers periodically, and when it flowers, it produces food for migrating hummingbirds. It's a mutualist as well. It lives the lifespan that we live, and it's there in the Mojave Desert, coexisting brilliantly with its ecosystem. Now, if we designed our cities to be much more sympathetic with their local ecology, perhaps we could do the same. And that comes back to your question also. There is no one size fits all. And the idea of Ho Chi Minh City looking the same as London is ridiculous. That city, Ho Chi Minh City, is just going to consume. It is not sympathetic with its local environment, just as London isn't. The Thames, incidentally, their fauna is completely decimated. There's a really good fossil signature of that too. I better shut up now and actually see Simon is.
There's one more question, I think, this gentleman here. The microphone's behind you, or two of them at once. There you go. You can talk in stereo if you want. Okay.
Hello. Excellent talk. I very much enjoyed it. I'm a reformed petroleum geologist. I now know better. But paradoxically, I've also been a cycle campaigner. And the last 20 years, I've tried to get cycle lanes installed in Glasgow. And at the current rate, I despair. I think in the next 20 years, it's not going to happen. I'm fairly pessimistic about the rate of change and affecting change, I must say. In some ways, I found it easier to get a well drilled than a cycle lane installed, well, not in Britain, but, I am not hopeful about the future. And in some ways, there's a part of me that says I don't care, because as much as I want my children to have a good life, and I desperately do, I also realize it doesn't matter for the world's sake. I don't know if you ever saw a book by Dougal Dixon,
Yes,
After Man.
beautiful work. Yes.
It's a lovely work.
Yeah, lovely work.
And he basically says, and man will become extinct.
Yeah.
And I went, in a sense, I kind of accept that. But then he paints a world where it doesn't matter that man's been extinct.
Yeah.
And I think, and part of me, that keeps me hopeful.
So Dougal Dixon's book's beautiful. Rabbits, yes. 100 different species of rabbits across the planet evolved from rabbits, and mountain rabbits and lowland rabbits, and yeah, it's lovely work. But I think, you know, from what gives us the right to degrade the biosphere in that way. So this is what's different. So the biosphere has been degraded in the past. It's been hammered at least 5 times really badly, and maybe as many as 20 times or more. It's had some serious hammering. In every single case, that was the driving mechanism didn't know what it was doing. The fundamental difference is that we know exactly what we're doing, and that is appalling. That's morally appalling. So I can't agree with you.
Well, I agree it's morally appalling, but having tried actively and actually worked in campaign and realizing that the change doesn't happen, even though 20 years ago, 30 years, 50 years ago, the change was necessary.
But it is happening in some places, yes. And I don't know what the situation is in Glasgow, but some cities have been really good in terms of putting in cycle lanes, and it needs protagonists like you. I mean, the alternative is, you know, I'm hearing what you're saying. You've been trying to do this 20 years, and I think that's brilliant. You know, absolutely applaud you for that. Don't stop.
No, I have no intention to stop it. It just, I know the change has to be massive. I know the Netherlands, and we have so far to go.
Yeah, Netherlands is way ahead. Yes,
I'll have to start winding things up there. So go to the Trinity Active Travel Hub in Irvine, where my wife works, and she'll help you get all the cycling stuff you want to do. Okay. We're 5 minutes after chucking out time. So if you want to continue this, folks, then if you want to go and join in with folks up at the Oran Moor, up at the end of the road, then we can continue talking about that if you'd like to join us there as well.
Yeah, that'd be good.
Be good. You must be exhausted already.
Okay, it's fine.
That's fine. You can get coffee, tea and biscuits. Yes, you can. Yes, you can get non-alcoholic tea there. Ian, would you like to give a little vote of thanks for Neil was sorry. Yes, it was Neil. There you go. Yes, thank you.
Right, before you all disappear, I'd like to thank Mark for this wonderful talk he's given, and also to say that Glasgow is probably one of the greenest cities in Britain, because it allows there's ways of getting through the whole city just in greenery the whole way across it. It's quite an amazing network through the river systems and the woodlands. So it's quite good, but as you say, it could be a lot better. One of the things that I did pick up on in your talk was first of all, you didn't talk about golden spikes. But you did show the different locations where these golden spikes are places where the stratigraphy is defined as the type location for the boundaries. And I'm sure a lot of us probably have our own ideas of where these golden spikes may be placed to have the greatest impact. Possibly. But you did offer a panacea solution to all this, which I thought very encouraging. You basically said that paleontologists should take over the world. And that's one I wholeheartedly agree with. So, I'd like to thank you, and I'm sure everybody else would like to thank you as well.
Thank you very much. Before you go,